All right, welcome everybody to Friday of the penultimate week of Computer Science 41. So today we're going to be talking about software engineering and software engineering is just generally the concept of like how do people program, the process by which people go about programming. One of my favorite professors at UC San Diego, Bill Griswold, I ran into last month or 2 months ago, I guess now at SIGC, and had some fun talking to him. And your last homework assignment, which you're going to be talking about today, is designed really to try and get you guys to think about the software design process. If I can sort of grossly simplify how students do coding, if you look at, for example, the timestamps of like when people finished Bitfield, which is graded today, right? Bitfield is due here at this time period, 12 noon today. If you look at like the timestamps of like when people committed the final thing, it looks something like this. And that's, probably, Friday. Some people do it a little bit earlier, but most students go right up to the deadline. Some maybe at like midnight the night before, but typically students will wait until the very last minute to do all of the work. And then what happens is that a significant number of them overshoot, and these are our optimists. Right? Students that finish, but they finish because they're too optimistic about their ability to do the code. So in computer science, optimism is not a virtue. You want to be pragmatic. You want to be able to know, can I get it done by the deadline? For the current homework assignment, it's going to be too big. It's too much work to do at the last minute. And no matter how many times you tell students, like, don't wait to the last minute to do the assignment, 90% of them will still submit their things at the last minute. So the final homework assignment is going to be designed to actually teach you how it works in the real world. Because in the real world, they don't give you like 2 weeks to just goof around and do nothing, and then you cram everything into the last minute and get it done. That's, your boss is going to be sitting there watching you play Call of Duty, and you're like, what are you doing? And you're like, well, you gave me 2 weeks to do it. I'm not going to do anything until the night before. It doesn't fly very well. They want to see you working on, every day on the project. And so what we're going to do for the final project, and this is going to be a big one, the final project for this class is going to be 50 to 60 points. So for those of you with a poor grade, this will be a lot of points that will allow you to recover from disaster. If you are in good shape, and you're an A-level student, then you'll be fine. The individual pieces are not that hard. So what we're going to do is we're going to give you this giant mountain of an assignment. This isn't a usage curve. It's literally just a mountain. And what you need to do with that mountain is you need to break that mountain into chunks. Okay, so rather than one giant mountain, you're going to break it into little rainbow colored pieces, and each one of these rainbow colored pieces is going to be worth 10 points. Okay, and these pieces are going to be due on different days. Which piece you do is up to you. So you're going to be handed this large task, and basically the first piece is going to be due on Monday of next week. The next one's due on Wednesday. The next one's due on Friday. The next one's due on Monday. The next one's due on Wednesday. And there is a bonus extra credit piece that is also worth 10 points. So if you fail on any one of these, you can still get 100%. Or if you do all of it plus the extra credit, you will get 10 extra credit homework points, which is quite a lot. It's like if you missed an assignment, it'll make up for that. Okay, and so this is because a lot of students have trouble breaking a task up into pieces. And so this is literally going to teach you how to decompose a problem into parts and solve the individual problems and then assemble them together into forming Voltron. And this will be good for you. It's not going to maybe feel great because it's a different way than what you're used to. But by breaking it up into chunks for you, it's going to force you to work on it every day or every other day until you get the giant project done. Each individual component is not bad, with the exception of one of them. Any of it can be done by a CSI 40 student, there's just a lot to it. And if I were to just give you 2 weeks to do it, it would be a train wreck. So this is what your life is going to be like for the next 2 weeks. Couple hours a day will probably do you. It's a partnered assignment. So if you want, you can work with somebody and sign yourself up on Canvas for a group for it. Okay. And so other things that we do in real life that people don't oftentimes do in college, like ongoing work, right? That's something that you'll have to get used to if you want to work as a software engineer in the real world. Like, not everybody does. Like, I'm sure you can find a place where people just sit around, doing nothing. I got paid for almost an entire year of staring at a wall. That was probably the worst job I ever had, honestly. I got all my work done so early, and they didn't want me to leave because they needed me. So they just paid me to come into the office and stare at the wall. I tried playing video games. They wouldn't let me. They said they couldn't pay me to play video games. They could pay me to stare at the wall. It's horrible. Yeah, it sounds great until you've done it for about 15 minutes. Then it gets old really fast. Let me tell you, it is not fun. I actually started starving. I actually didn't have enough money to pay for food at the time because I could go in and work as much as I wanted, but it was just so miserably painful to go in there and stare at a white wall that I, even though they're paying me decent money to do so, I couldn't do it. Stared at a tree for 5 minutes. Yeah. Me too. Okay. Another thing that we do in real life is Git. And so Git and GitHub, GitHub is a website that hosts Git repositories. This will teach you how to use GitHub. GitHub is sort of the de facto standard for code sharing and code repositories and source code management. Source. It's a pretty ugly C there. Let's try that again. Source code management. So if you haven't used Git before, this will teach you how to do it. You're actually going to be submitting your homework on Git. So I will be looking at your Git repos to grade your homework. So you need to know how to do this in the real world. And normally I do something earlier in the semester. Just this semester, it didn't come up. So you will have to learn how to use GitHub. We'll have a little bit of a lecture later on this. GitHub, source code management. Let's see that thing. Agile, I guess. Agile, and then also we'll be doing TDD for this. Okay, and so what is Agile? What is TDD? I've got a lecture queued up on that I'll get into. But basically, this is kind of this assignment's going to be designed to teach you like the real world, kind of stuff. And so, what is the assignment? Okay, the assignment is designed by you guys. It is a combination of volleyball. Yay. It's a combination of battleship. Yay. And it's a combination of Jeopardy. Yay. What have you done? You guys designed this, not me. It is going to have networking. ... Evil face, evil grin. There we go. And it will have what's the other thing? Oh, TUI, text user interface. So you're gonna have to design a text user interface. All right. So each one of these bullet points is one of those rocks. Okay, and you can do these in any order you want. So each one of these things is going to be 10 points. And so if you just never figure out networking, you're down 10 points. And so you can make up for it by doing TDD, which again, I've got a lecture I'm going to start in on in just a second. And so if you do 5 out of the 6, you get 100%, 50 points. If you do all 6, you get 10 bonus points. So like I said, each one of these things is going to be due every couple days. Okay. You're going to use GitHub to submit it, and you're going to like it. Yeah, this is going to be good. Mincarelli says this is the best homework assignment he's ever seen for 41. I think it's probably, I don't know, at least the most difficult assignment for 41. Okay, but that's why we're breaking into manageable chunks. Okay, and that's why it's worth 50 points, so that students have that not intrinsic. They have the extrinsic motivation to do it, because otherwise half the class would just not do it. All right. But each of the individual chunks are actually, I think, quite doable. Networking being the only one that you might actually struggles with. For example, the Jeopardy part is just literally opening up a file and printing a question and getting an answer and saying if it was right or wrong. So that's a CSI 40 level task. You can easily do that by Monday. All right, so here we go. So today we're going to be talking about the software development lifecycle. We're going to talk about the waterfall way, also known as the wrong way of doing things. The traditional way of doing things, let's put it that way. We're going to talk about Agile. Agile is a giant buzzword these days. The US military has conferences on being Agile, which is hilarious because they're the living embodiment of not Agile. We're going to talk about TDD, test-driven development. We're going to talk about GitHub, version control systems, and then we'll talk about more on the assignment here. All right, so anything the government does is the opposite of Agile. Yeah, it's really bad. Like New York time card system failure. So the longer the law, the faster the law. Yeah. So the government is like slow and efficient. It's the opposite of everything that kind of like Silicon Valley and tech stands for. But anyway, this is the software development lifecycle they use because it results in contracts and money flowing, and you can have accountability and things like that. So it's still fairly popular. I used to work for a defense contractor, and this is kind of similar to how a lot of the defense contracting stuff would work. So let's say you get a contract, and the contract is to do a time card system. And how many people here have used like a time card system? Like you punch in, you punch out, and then that kind of measures how much time you are working, and they pay you based on your hours, your hourly rate, not a physical one, but sure, yeah. Like they have like a digital time card system like at our college, for like tutors and things like that. And so in New York, they found that a lot of employees were cheating on the system. People were punching in their friends, and then when they leave for work, they'd punch out their friends. And so their friends would just be staying at home, smoking pot and getting paid full-time salaries for not doing any work. And this was a big scandal. So they said, okay, we need to make a new time card system. And so they offered, $100 million, let's just say, to a company to make a new time card system. And no, the dream is not sitting at home smoking pot and getting paid for it, but to be the people making the $100 million time card system and failing and getting paid for it. Mm-hmm. So here's how the traditional software development lifecycle works. You're awarded a contract. You have 12 months to make a new time card system. First 2 months, you sit there and you gather requirements. You talk to people, you go to the hospitals. You're like, all right, when do people punch in? When do people punch out? And then they mention things like, lunchtime, people will punch out for lunch and punch back in for, coming back from lunch, coming back from break. So we need to have a system where they can check in at the beginning of the day. They can check out to go to lunch or a break. They can check back in. They can leave. What other things do you think they would need for a time card system? What do you guys think? I'm asking you guys. You're the hospital, right? And I'm the person who's designing the system. You need to tell me what needs to go into the system for it to be successful. What do you guys think? Timestamps. some kind of security authentication. Yeah. And more than that, I think they wanted like biometric identification, right? So you can't just like get your friend's username and sign them in. You actually have to like put your thumbprint on it or retina scan or something, right? What else? Timestamps, okay. Lunch. What if somebody forgets to come back from lunch? Or what if, or more importantly, what if they come back from lunch and they forget to check in? Then what? You know, what if you can edit it? Yeah, you have to have some sort of system where, like, if you make a mistake, then you can adjust your check-in and check-out times, right? But now that's available for abuse also, right? Because somebody could just like, you know, take a long lunch and then move when they came back in earlier, right? They could take a 3-hour lunch and then adjust it to be just like 1 hour, right? Editing can only be done by higher ups, so you can't spoof it. Yeah, so you'd have to have some sort of like management role and like, you know, like, so you have to have roles, and so you sit there and you like write all these things down, right? Confirming hours, right, by the employers. Yeah, that's how our time card plus system works. Like when I have a student employee working for me, they send me a thing with all of his hours, and I go, yep, approved, you know, and send it back in. There's a lot of pieces to this. And I have to sit there and gather all of those pieces by talking to people. Like, how do you use the system? What's wrong with the current system? What do you want in the new system? Et cetera, et cetera. Then we sit down for 2 months. And remember, you're only given 12 months to do the whole thing. And now we're 4 months in. Because the next 2 months are spent creating a design document, a specification document that specifies every function we're going to have in the system, the way the system is going to work. This is how they're going to log in. This is the database we're going to use. You create this big chart showing all the different pieces and how they connect to each other, looking like one of those 9/11 conspiracy people that are like, okay, we'll see, you know, the preschool that George W. Bush was at, you know, and you like draw the lines between everything. They'll typically, yeah, exactly. They'll typically do one of those charts showing like how all the different classes connect to one another and how the functions call each other and things like that. Okay, that takes 2 months to do. And then this whole system is ridiculous, by the way. But like the nice thing about this is that this is like a contract between you and the client. So if the client signs off on your specification document and you do what's said in the specification document, you get paid. That's why they like it. It's not a great system for like getting work done, because guess what? You don't know in advance what functions you need, right? You know what functions you need as you need them, right? And so guessing like, okay, I'm going to need a function that takes a vector and returns the maximum value of the vector or something. Like in practice, like you might decide like, oh shoot, that's too slow. I'm going to switch out for a hash table. Well, sorry, you know, the specification document said it's a vector. You have to do a vector, you know, and so you're sort of locked into making all of your decisions before you start working on it, which is a place in time where you have no idea what you actually need. So it's just destined for failure. You then have 3 months out of the year to actually do the coding. So there you go. Make the entire thing in 3 months. I don't know what your coding team is doing the rest of the year. Presumably the other steps as well. You then do testing. So you do unit testing. So you test every function, you test every class, and verify that the functions and classes are behaving the way you said they are. And you hand out the different pieces to different people. So Kush gets handed the max function, and BD gets handed like the fingerprint function, and Messick gets handed the ability for managers to authenticate things. You just kind of hand them all out to people, and they kind of like work on them according to the design spec, and the design spec says very exactly, this is what your code's going to do. And then the magic happens. You bring it all together and hope and pray that it works. That's why I call it magic, because it doesn't, right? Like one person has the data stored in a vector backwards from the way the other person does, and none of it makes sense, right? And so you have to sit there and you have to integrate all the different pieces with each other, and it's a giant mess. That takes another 3 months. So now we are 10 months in. We got 2 months left. So now that everything's done magically somehow, we have 1 month to install it over at the hospital and deliver it, you know, install it, test it, make sure everything's kind of working properly. And then we have 1 month for debugging. So as the customer finds bugs, they send them to us, we fix it, and push out patches and things like that, and then we're done. And then if they want more bug fixings, they need to pay us for a service contract to pay for programmers to be on staff to service the system and keep the bugs out. Or if there's enough feature requests or if there's enough bugs, then we start with phase 1 again, and we start gathering requirements like, okay, well, the fingerprint system doesn't work. Let's try replacing it with a retina scanner. And you're not going to debug that. That's a new feature request. And so you're going to push out version 2 for another $100 million, right? And this is called the software development lifecycle. You do requirements analysis, you design it, you implement it, you test it, you then debug and gather new requirements, and so on and so forth. The trouble is the system does not work very well. But if you've ever heard like version 1 of a program, version 2 of a program, version 2.1, that's kind of based around the notion of the software development lifecycle, that you can have these major releases. Office 2020, Office 2021, Office 2022. You have a major release every year. And I mostly don't do that these days. Like mostly, when I come up with an edit, I just edit it, and this is release Cinco de Mayo 2023. Like whatever. The version number is literally the day that I release it. So, I don't even. 3 out of 12 months coding seems crazy. It is, and it doesn't work either. So here's a more detailed version of the waterfall model, and this is called waterfall because if any step goes wrong, like if you're implementing and then like it breaks, like the thing just doesn't work, you have to start over and redo the spec document and the design document and things like that, and you kind of start from scratch over and over again, over and over again, over and over again until it works. And guess what? It doesn't work. It doesn't. So if you look at the actual performance of Waterfall versus Agile, which we'll talk about in a second, you can see that out of these are like major software engineering projects, only 14% of them succeeded. And so we're talking about software engineering projects that are like $50 million budgets, right? Like replacing the radar systems for the FAA, replacing the time card. And they failed, by the way. Like they tried replacing the time card system in the New York hospitals, and they failed. Like they were given a budget of millions of dollars and were not able to come up with a replacement for the time card system. Like there's no other industry where like you could just like hand somebody $100 million to make a time card, and they're like, nope, we don't have anything. Sorry, we failed. We tried building the bridge, but it didn't work. So we don't have anything. I'm sorry. Like there is no other industry where people would put up with a 14% success rate. You try designing the next Nissan Altima, right? And you have a 14% chance that the team is going to turn in a new car. Like you're working for Nissan. You're like, all right, you're the team that's going to design the 2025 Altima. And there's a 14% chance they actually complete. Like what? Like nobody would put up with that. That's absolutely unheard of, like in any other industry, for there to be a 14% success rate for major millions of dollars projects. We're not talking about hobbyists who are just like in their home garage, like making a video game, they get bored. No. We're talking budgets of millions to do stuff that you wouldn't think is actually that hard. I mean, maybe it is. Like doing like a new radar system is I don't want to do it. But you offer somebody $100 million, I take a crack at it. I mean, I could fail to complete. I could fail to complete. Like if they offered IBM $100 million to do the new radar system for America, I could fail to complete it in half the time and half the budget. So just saying, FAA, come talk to me, and I am more than willing to absolutely potato on a project at a discount rate, like no more than $5 or $6 million. So compared with like what IBM is going to charge you to fail, this is the lower bid right here. So, okay, so what is Agile? So Agile is a methodology where you don't assume that you know everything in advance, because you don't, right? You don't know every function you're going to write. You don't know every feature you're going to need. You just don't. It's an iterative process. And this is what I have been trying to teach you guys for the past 2 semesters, which is like when you're coding, you write a little bit at a time. You write a little bit at a time and you test it and you make sure that it works. And you write a little bit more and you test it and run it and examine it and try edge cases on it. And then, okay, that looks pretty good. You work a little bit more. So Agile involves what are called like sprints. So like you spend a week working on like a single small part of your thing. So like if you're working on, the New York time card system, this week we're working on a fingerprint reader, right? And so everybody gets down and we buckle down and we get it knocked out by the end of the week. And then you release it to the client. You're like, hey, here's kind of our mock-up for like the fingerprint reader. And you put your thumb on it and it says, yes, this is Kearney. No, it's not, And then the client gives feedback. The client's like, it's cool, but you kind of set the fingerprint reader up too high. We got a lot of short people in our department. You need to put it a little bit lower so that people that are shorter can hit it. And you're like, oh, shoot, you're right. And then you revise, right? So you're constantly pushing out releases to the client. And it's not done, right? Like you don't have like the manager time approval system. You don't have the ability to adjust, if somebody forgets clock in or clock out. That's not done yet. You just have done the fingerprint reader. And, you test it and you push it out and see if they like it. And, and they might have major changes, minor changes. A lot of times the changes are just cosmetic. Like I was working on a project about 6 months ago and we had hired a Romanian guy and he forgot to put zip codes into the thing. And because I guess they don't have zip codes, I don't know. And we're like, hey, you need a zip code, if you're doing, this thing for America. Oh, okay, shoot, And so you just constantly are like giving feedback. You look at it, you're like, the font's terrible, fix the font, put this in, change this. And the client is constantly happy because they're involved and they're getting to kind of control the thing. And you get to make changes early on before they're like baked in. Like if you had the fingerprint reader up here and everything, and you have this whole chassis and this whole thing and it glues to the wall, and then somebody's like, oh, we need the fingerprint reader lower, that's going to be an expensive redesign, right? Because you've put this whole, like the retinal scanners here and the thumbprint scanners here, and if you move it down to here, now people can't get their eye down to the retina scanner. Like you want to make changes early. Changes are cheap when they're early. When they're late in the design process, they're expensive. And so by releasing prototypes and tests early on, you can get that crucial feedback. Like, like what if somebody's in a wheelchair? They need to be able to hit the thumb. They can't get up there. They can't retina scan up there either. Like, oh, shoot, you're right. And so you get those feedbacks early. That keeps you from having these huge cost overruns and failures to complete a project. So, so the Agile approach is 300% more likely to result in success. Okay? And the challenge thing, if you're wondering what the challenge thing means, that means that the project went over budget significantly or over time significantly. So in Waterfall, 1 out of 3 projects just fails outright. And only 14 are outright successful, like completed on time and on budget. With Agile, you have a 42% on time and on budget, and only 9% fail, which is still bad. Software engineering is a terrible industry. Like, it really is. Like, there's no other industry as bad as software engineering that I'm aware of. Where you just, like, hand money to somebody and they spend it and you don't get anything for it. If you hire an architect, they'll give you some blueprints. If you hire, I don't know, somebody to build a bridge, like the construction company's going to build the bridge. You know what I mean? Like they don't just like pocket the money and be like, no, you don't get a bridge. Give me another 100 million, Okay. So Agile development, you release quickly, you release often. And that's what I'm going to try and teach you to do for this current upcoming homework project, because you are going to be doing a release every 2 days. Okay? Basically, Monday, Wednesday, Friday. I am blurry. Look at this. Woo. Woo. No, maybe. No, still blurry. Okay. So you're going to release it quickly, release often. You're going to get feedback to drive the next cycle. I'm not going to give you guys feedback because it's too much work. But you're going to release you're going to put it up on GitHub every Monday, Wednesday, Friday for the next 2 weeks. Okay, time to use Git. Yeah, you're gonna release on GitHub every Monday, Wednesday, Friday for the next 2 weeks. You're gonna be pushing out releases. You're gonna screenshot it to me, and I'm going to grade them a lot. It's gonna be a lot of grading on my part, but I think it's useful. I think it's gonna be good to teach you how the real world works. And so these things are called sprints, and they do stand-ups. Stand-ups are something that's used everywhere these days. A stand-up is a meeting where everybody stands up, and the reason for that is because people get tired of standing, right? The trouble with a meeting is that you have like 10 people in a meeting, and at any point in time, there's like 2 people that are actually talking to each other, and the rest of the people are just sitting there, just like waiting for the manager to like get to them and like talk to them. And then the manager just slowly goes around the room, and 15 minutes a person, times 10 people, you're talking about 2 hours and change. And so you've had 10 people in a room for 2 hours. That's 20 man hours of time to do 15 minutes of work. That could have been done by the manager just coming by your cubicle and talking to you for 15 minutes. It's a complete meetings are like the absolute worst thing for productivity, for morale, for any of this stuff. It's very rare you actually need a bunch of people in a room. That's usually like project start, like when people are like designing something. Yeah, you want to have everybody in the same room. You can like get out a whiteboard and kind of like sketch out things and like make sure everyone's on the same page. But most meetings are just a absolute pathetic waste of time. Like you've just paid, like if you think about it, like you can have a bunch of highly paid engineers in there. They're getting paid $200 an hour, and you just spent 20 man hours of work. You just spent $4,000 for that meeting, and how much money did you spend on food? You spent like $5 on a dozen donuts. Like, come on. Like, it's like they're absolutely willing to just waste people's time and pay their salaries, but they can't even come up with like carrot sticks and ranch or something. It's terrible. So basically stand-ups are like a thing that people do these days because you can't get comfortable. You're literally standing there, and so they just go around like boom, 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 boom. You get to hear what everybody's doing really fast, like, and they do this at like hospitals, like before they go rounding around the hospital, they'll do a stand-up, and just everybody can be on the same page really fast, and then they go. And then on Fridays at the end of the week, they'll do a retrospective where they will like talk about the last week, and they're like, hey, I tried getting the thumbprint reader working, but it didn't work. I pushed too hard and I broke it, so that's something we're gonna. And so there are times when you need to actually share like what you've found with the rest of the group, but again, you do it standing up, so you can't get comfortable. You're like, hey, this thumbprint reader is great, but we're going to need to like reinforce it or something, because like I just jammed my thumb on it and it went right through the plastic, and I have blood coming out of my thumb now, and it hurts. So with Agile, it keeps you from sitting down. Like you just have to go fast, fast, fast. And then the managers, their job is mostly to interface with management, like the CEO and things like that, and to protect the development team from getting distracted and getting interrupted, which is a constant bother. When you're coding, there's nothing worse for your productivity than getting called to a meeting. You come back in, and then somebody like wanders by your thing and starts talking to you. And sometimes it's fun. It's like, the marketing guy and the next to me, he was a really cool dude. He's fun to talk to. But like, I'm not working, and then I'm like, okay, what was I working on? And it's a distraction. And so ideally, the Agile manager is like interfacing with the clients and like getting their feedback, and interfacing with the CEOs and getting their feedback, and keeping the development team just nice and not distracted and able to work. And really not having meetings like except 15 minutes at the start of every week and at the end of every week. It really does distract you if you're in a mood, like if you're programming. Yeah, it does. So Scrum is like a very popular Agile methodology. My sister's a Scrum Lord. And so basically they come up with a definition of done, which means this is how we know we're finished, which is actually really hard in computer science because products are never like finished. How do you know when you're finished with Microsoft Word? This is it. We're done. We're not going to work on right? Like you don't know. Like, there's always something to be done, right? When is Dwarf Fortress done? They've been working on it for 20 years, and they're adding in new features all the time. Like babies and different dancing styles, and cats that lick their paws and get alcohol poisoning because they're walking on the floor of the bar. Like you're like figuring out when you're finished is actually really hard in computer science. There's no ending point, right? And so I give you guys a definition of done. You get an input tester, and the input tester tells you when you're finished, right? And that's TDD. We'll talk about that next. But in Scrum, you come up with some sort of thing. Like, we're going to have the thumbprint reader done by this week. And you create a backlog which holds all the tasks that have to be done. Somebody's going to have to like contact a supplier and get demo thumb readers. We're going to have to get pricing information. We're going to have to get drivers for it. We're going to have to build a chassis for it. We're going to have to do all this stuff. All these things get added to a backlog. And you do daily sprints, weekly sprints, monthly sprints. And you ship out these incremental things to the client. The client gives you feedback. And those things get pushed into the backlog. And so you get something like this. So as you're working on it, you're like finishing tasks. Then you discover some bugs. And so the project manager will throw some new tasks into the queue. Like, hey, you got to figure out why this thing's crashing. Hey, why is the thumbprint reader catching on fire when we push on it? That seems like a bad idea. And so sometimes the number of tasks you have goes up. But on average, what you want to see is the team burning through the backlog. And there's tools for doing this like Jira, things like that, that track all this kind of stuff. And you're kind of like burning through it. And ideally at the end of, in this case, it's a 3-week sprint. At the end of the 3-week sprint, you've got all your work done. You have a retrospective, what went well, what didn't go well, what can we learn about this for next time? And then you start the next sprint. Okay, now we're going to be working on the ability to adjust time clocks or whatever. And you release an incremental release to the client. They give you feedback on it. We love it. We hate it, whatever. And then their feedback gets tossed into the backlog as well. Okay. So next topic is TDD. TDD is the notion that you write your test cases prior to writing your code, which seems weird, right? Like you have to write your code before you test it, right? Maybe it's not that weird for you guys because we have an input tester, right? In this class, you're given the test cases prior to writing the code, right? You're handed, test cases, and you're like, make your code do that, right? That's TDD. So, it's maybe not that mind-blowing, but if you were out in the real world, like a friend of mine was like a test master for like Microsoft. It can be hard to get programmers to see the value of test-driven development because they don't like writing tests, and they especially don't like writing tests prior to writing the code because they don't know what it's supposed to do, And so it can be there can be a real culture shock on it with like a lot of people like, I'm not going to do that. But there's a lot of benefits to TDD. For example, let's say you're working for a financial services company and you need to calculate compound interest, right? So what you can do is you can work out in advance, like if somebody takes out a loan, 30 years, 3.8% compounded monthly, blah, 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 blah. Here's the principal, da, da, da. You can say, this is how much you're going to owe on the mortgage after 7 years. And you calculate it by hand, and then you create a test saying, if you have, this is the interest rate, this is the principal, this is the this is the answer. And you create all these test cases prior to writing your code. And that will, and you cover everything. Like, what if there's a 0% interest rate? What if there's a negative interest rate? For like quantitative easing. What if, what if the principal is between 0 and 1? Is that handled? What if the interest rate is between 0 and 1? Is that handled? What if hyperinflation? You create test cases for a wide variety of scenarios, liberally sprinkling in zeros and ones and negative numbers and things like that. And you create all these tests. And then what you do is you run the tests. And you run the tests and you fail them. You should fail them. If you're passing all of your test cases, and you haven't written code yet, there's a problem. There's a problem with your tests. If you can pass all of your tests without writing any code, your tests are probably bad. So you start off, you write all your test cases. Your function just probably stubs out, like return 0 or something like that. You compile it, you run it, you test your code, and everything's red. And that's good. You want to fail. Like I said, before you've written your code, they should all fail. And then as you start writing your code, you'll start seeing tests turn green as like you guys have all seen this. Like you write, one of the Bitfield classes and you compile it and input tester. And look, I just passed 3 more test cases. It's a good feeling, right? And the even better feeling is when everything turns green. When you have test pass, test pass, test pass, test pass. Boom, you're like done, right? So this is a definition of done, and that's one of the best things about TDD is that it'll actually tell you when you're finished. Like, there you go. If you pass all the test cases, you're done, because you've made a test case for every edge case you can think of, right? If you've got very thorough testing, you're done. You're passing them. You're correct. Your code's correct. You've implemented everything you need to implement. You're done, which is nice because, like I said, a lot of times one of the hardest things in computer science is knowing when you're actually finished with something. So after you're finished, though, you're not finished. Then you go. This is called red-green refactors. You start off, all the test cases are red. You pass all the tests. All the test cases are green. Then you go through a cycle called refactoring, where you are like, this code's not fast enough. I'm going to replace this vector with a hash table. And a lot of people in old code, they don't like doing that because they're afraid they're going to break something, right? You do not touch the ancient codes. Here's one of the nice things about TDD. If you have TDD, if you broke something, right? Like, you got all this code and it uses vectors and you replace it with a hash table, you rerun the test, it turned red, like, oh shoot, I broke something, right? It'll even tell you, like, you're not handling negative numbers now or something. Oh shoot, you're right. And if you refactor it and it stays green, you didn't break anything. It's really nice. Most people are too afraid to actually change old code because they don't know if there's some side effect they're gonna, like, they just don't know. But when you have comprehensive tests for a function, you check in your code on the source code management, and that's something we'll be talking about next on GitHub. You save your work, and then you make a new version that switches out those vectors with hash tables. You rerun the test. Oh, I broke something. You fix it. You rerun the test. It's all green now. Done. It's faster, and I'm guaranteed not to have broken something because my tests are good. You check it in, version 2.0, ready to go. And you can drop it from order N to order 1 or something like that. So, rule of thumb, don't trust yourself. Yeah. Yeah, that's TDD will give you that trust. It'll give you that feeling of security that you have not broken it, because you never know. Like without TDD, you change something, you got a million lines of code. I'm not changing anything, man. you run the program once, okay, it seems fine. And then you release it to the world, and people start writing back, I'm getting a seg fault now whenever I try changing the font. And you're like, shoot. Yeah, that change that I made, yep, that broke it. And now all of your clients are mad at you because you push out a change that's crashing their systems. With TDD, you have that safety. You have that feeling of security. You can be brave to make changes. Okay. So, and this ties in a lot with a version control system like GitHub. So that, when you refactor, if you break it, you can just go back to the previous version, right? The downside of TDD, tests can actually take a really long time to run, right? Microsoft might have 100,000, 200,000, 300,000 tests for Cortana, right? And so if you want to know, did I break something? Come back tomorrow. It's like, hey, you're not going to run 300,000 tests like instantaneously, not even at Microsoft. And so like you might run 10 tests or 20 tests just to get like a quick, like, did I blatantly break something? Yeah, here's what a G-test looks like. And this is what your extra credit is. So G-test will show green for any of the test cases that you passed and red if you broke something. Very nice. That's G-test, G-unit, 50 cents. So yeah, TDD can take a long time to run the tests. So oftentimes they'll sort of offload them to like nightly test builds. So they'll run the entire test suite overnight. When you come in the morning, you find out, you broke test 72,963. Like, okay, what is test 72,963? You look at it, you're like, oh shoot, that test is wrong. Yeah, we changed that. Like we now allow negative interest rates because of quantitative easing. So yeah, and that's another downside, which is that your tests will become stale. As the world changes, like maybe now negative interest rates are a possibility where they weren't before. And so your test could be wrong. Like your code could be right and your test could be wrong. And so you have to maintain both of them, which is annoying, which is one of the reasons why a lot of programmers don't like doing it, is because your code will get old and out of date, and your tests will get old and out of date, and updating 100,000 tests, you don't want to do it, right? That's a lot of work to maintain 100,000 tests. So Discord crashed. Test cases can also make you test things right in the board. Can you guys still see me here? Is it still streaming? Make sure you're all good. Okay, cool. Right, and so there is quite a lot of effort in actually maintaining your test cases. So a lot of times they'll actually hire a test engineer, or they'll hire a person to like write tests for the programs, because a lot of programmers just don't like doing it. And there's this constant like culture clash between people that like TDD and people that hate TDD with a burning passion. And like putting them on the same team is just like cats and dogs, like like just not getting along with each other. Because one of the groups is constantly pushing for more tests, automated testing, code, like having code stamps like given by the AI. So like you write code, in order for your code to be accepted, it's got to pass through the gauntlet of 100,000 tests, then it signs it. And then the other people are like, just let me write my code, dude. Like lay off me, man. And there's a lot of things that TDD can't test, like video games. Like you can't really test like a rocket launcher. You know what I mean? Like they have like mock things for a lot of things, but like it's really hard to simulate like people in a video game and make a test for it. Like where should the AI go? Like I guess you can set up a world with like people in it, and but like in a dynamic environment, like a first person shooter, like it's probably too much work to do it. That'd be like QA. No, I mean there is QA, but there's actual software engineer positions that are like test engineers, and what they do is they build the tests, they work on the test suite. There's like a harness that will run all of the tests. They automate that so that like when somebody pushes a change to GitHub, it'll start running all of the tests on that code and make sure that it's validated. And then if a test breaks, like they fix it. Like that's an entire job that you can do. And I've had friends that was their job. Like they were the TDD person. And TDD is kind of like everywhere these days, but like to what extent, it's used. A friend of mine who worked at Pandora, who'd asked the question of like, what percentage of your code should be covered by a test? Right? 75%, 80%, 100? And no matter what number you said, he asked you to defend it. Like, okay, why 80? Why not 90? 100, don't you think that's unrealistic to test 100% of your code? So it's everywhere. There's just, it does add overhead to your work. But most TDD supporters would say the overhead of making the tests and maintaining the tests is worth it to know when you're done, when your code's correct, and if you've broken something. And that gives you courage and bravery to actually make changes and maintain your code. Because otherwise people just will not touch old code. They're just like, it works, just leave it alone. Well, if there's a bug, if I fix the bug, somebody might be relying on the bug. I can't fix it. I'm leaving it alone. And so you incur, technical debt and all this kind of stuff where like, it just sort of festers for like forever. That's how spaghetti code is cooked up. Yeah. You get into an unmaintainable situation where you just have old code and you're just like, I don't even know. I don't even know, man. I don't tell you. And people make just the smallest changes possible. Okay. Version control systems. So nowadays, we're talking Git and GitHub. If you've never used Git or GitHub before, I'll do a little demo for you in a second on how to do that. But basically, there's two main reasons to use a version control system. The first is if you delete your source code, which I think 3 people on the last homework assignment did. Like, I deleted I deleted main.cc. Is there any recovery thing on the server? And the answer is no, there's not. Use Git. Okay. So even if you're doing like single user coding, if you use Git, you can check in checkpoints basically on your code. You can essentially save different versions of your code, version 1, version 2, version 3. And if you ever screw up or you delete it, you can recover. And if you can you do a workshop for Git? I'm gonna do a workshop on Git right now. Or if you mess up your code, you can revert back to a previous working version. And so you can have bravery to do revisions and things like that. And if you just completely screw it up, like I don't even know what happened. I know I'm missing a parentheses or something somewhere, but nothing is working now. I'm getting 900,000 template substitution errors. I don't know what went wrong. You can just rewind to the previous checkpoint and start again, like in re0. So there are other alternatives to Git and GitHub. I like Mercurial, actually, myself. I actually kind of prefer it to Git. Git has issues. Every major company I know that works with Git has had issues with Git at some point. And we're not talking stupid people either. We're talking like Microsoft and people who are experts in Git. They will get into a situation where they're like, everything's broken. I don't know what happened. Let's drop a grenade on the whole thing, back up the whole repo, start from scratch. I don't know how to fix this. Or they come in and they bring in an expert and he's like, oh my gosh, what did you do to this? And every company I know has had major problems caused by Git. It's really good at what it does, but it's also really easy to like stick into your own bicycle wheel, that one, stick and bicycle meme. This guy here. Yeah. This is Git. I don't know. I don't know what these have to do with GitHub. Git. It's fine. I don't know. But yeah, basically that meme for Git. You starting Bitfield last night. It's a mistake. Okay. Optimism is normally a good thing. It's not good in computer science majors, especially when you're a student. Especially when you have a deadline where like this is the cutoff and you're going to get a grade. Do not be optimistic of your abilities at all. Always assume it's going to take longer than it should. I learned that the hard way, and so I started trying to have everything done at least a day beforehand, so that when something would go wrong and things would go wrong, I'd have the time to fix it. Okay. So basically, with all these different version control systems, you can like sort of check in your code, and you can check out the code as well. And so it's like in the old systems like Subversion and CVS and RCS, like you would literally check out a file, and now I'm the owner of the file, and nobody else can modify that file. I own it, and then I edit it, and then I check it back in, and now it's unlocked, and somebody else can check it out. Git doesn't work that way. With Git, basically everybody can modify any file. And if two people modify the same file, you get a merge conflict, and then you got to go through the process of resolving, you modified this function, I modified this function, you like kind of put them together. Git was made by Linus Torvalds as a way of like handling all of the different changes to be made to the Linux kernel. But it's not good at like video game development, assets in particular. Like you have an 8 gigabyte texture or something, stick it in Git is absolutely miserable as far as performance goes. So there's other systems like Perforce. Perforce is typically used for game dev. Perforce sucks also. Like don't get me wrong. Like they're all bad. Like they're all bad in different ways. Like there's no version control system that I actually am like, oh, that's great. Mercurial is probably the closest for that, but nobody uses it. So I don't know. But Perforce is like the standard for game dev, and it's terrible also. I just want something that works, man. I don't know what to tell you. Okay. So, the other reason to use version control systems is for having two different people coding together, right? So it's useful just on your own. So you can like save and like checkpoint your files. So you can revert if you have to. But it's really useful when you have two people working on the same project. So for the current project, you're going to have a client, you're going to have a server. So that allows me to work on the server and you to work on the client. And I could be uploading new copies of the server code. You could be uploading new copies of the client code. But then I can pull the client code down. You can pull the server code down. And we can sit there and be coordinating our efforts with each other with a surprisingly little amount of effort. Okay. So being able to have multiple people working on a project together is really nice. And let me show you kind of what that looks like. Okay. Okay. So let me do a little demo of Git now for you. Actually, I'm going to stop this recording and then I'll make a separate recording just on Git so that students can just flip right to that recording.